we look at benzene. Now, what's this called? Once I finished drawing it. Cyclohexane. And if I were to write the molecular formula for cyclohexane, what would it look like? C6H12. Well, we sometimes we might have a cyclohexene as well, mightn't we? In which case, that would be a cyclohexene.
Yeah, they have 3 bonds in one of these. Like, the carbon's bonded 3 ways.
Yes, it's possible, but it would be very reactive. It would be quite unstable. Anytime you have a triple bond, but especially if you've got some angular pressure on it.
Or did you just add that?
Sorry? I just added a double bond to make cyclohexene. Right. Now, what would this be? Benzene sometimes gets confused by students with the cycloalkanes, but it's actually C6H6. Okay, and what we do is we draw this circle in the middle of it as well. If you look on your formula sheets, you've got benzene on your formula sheet. If we were to write it out with our bonds the regular way, we would do that. Okay, we would draw it out as alternating double and single bonds. But this is not a very good way of representing it because, well, for one thing, it's inaccurate. But the bond length of a double bond is shorter than the bond length of a single bond. And so this would then be shorter and longer and shorter and longer and shorter and longer. And so it wouldn't have that same symmetry as it has in reality. And so what actually happens is we end up with a bond length of 1.5 in the benzene. So it's halfway between a single and a double bond. You don't have to worry about bond length in our course, but that's why we represent it with this circle in the middle, is to say that all the bonds have the same length, and it's a part way between a single and a double bond. It has this special stability, and from this sharing of electrons here in this ring, and I guess a whole other side of chemistry. So this is aromatics. You might remember that we talked about the organic molecules that we were looking at as aliphatics. And so the aliphatic molecules are like our straight chain or our cyclohexane, so they can be cyclic, but they don't have a benzene ring, like this sort of arrangement, which are the aromatics. They're called aromatics. Why do you think? Because they smell. Okay, there's a lot of pongy organic chemistry happens with these sorts of rings. Now, when you're naming them, which is what we're sort of interested in here, we're just going to use benzene on the end, and we don't look at many varieties of our aromatics. We just have a few in here, and so something like this it's very straightforward. It's just 1,2-dimethyl, which is how we'd name that anyway, isn't it? And then benzene. Yeah, and so we number in the same way. We want to make out the numbers of our side chains have the smallest number possible. The only difference would be this one. There's a phenol, okay, that doesn't have benzene. You could call it benz alcohol, something like that, if you weren't sure. I don't think you're, because this is such a small part of our course, if you sort of muddled up your naming a little bit, it wouldn't be the ends of the earth. And then benzoic acid. Okay, so because it's an acid, we still need its name to end in acid, and the benzaldehyde. But most of the time when you come across a question with the benzene ring in it, you're just going to probably need to count carbons and hydrogens. A common mistake students make is forgetting that once you have a bond here, then there's no other hydrogen there. Remember how, if we think of C6H6, then we're talking about one of each of those bonds off to a hydrogen. But if I add a methyl group on there, say, well, then I've taken away one of the hydrogens from the ring and I've replaced it with this methyl group. So I would have, that would be C7H what? 8. Does that make sense? Yep. Really good solvent, and I used it at uni. It's actually carcinogenic, and you don't even use it at uni anymore. Toluene is based on a benzene ring, and you might have, I don't know, whiteboard markers and texters. Some of them used to have toluene as the solvent, and for a long time they would write on the side of a marker and say, oh yeah, this one says toluene free, just to let you know that they've produced basically one that's not using toluene as the solvent because of that carcinogenic effect. Can you maybe go